Hi everyone, my name is Theodore Tran. I worked with Dr. Ted Hilar and our PI, Dr. Court Anastasio. We're from the Department of Land, Air, and Water Resources, and my research was on nitrate photodegradation in snow. So before I started working in this lab, I had no idea that snow could be so photochemically active. One such chemical that's in this medium is nitrate, and it can change its concentration and act as a tracer for atmospheric pollution in ice cores. So in figure 1, nitrate undergoes photolysis through two channels. It can create nitrogen dioxide or nitrite. And the reason why we study nitrate in the snow is because nitrate can be found abundantly in real-life snow, and it's used to understand past levels of nitrogen pollution. In addition, the production of nitrite from nitrates can enter the atmosphere and change the chemistry of the air when ice is melted. And this can ultimately produce smog. Before I move on, I just want to clarify that nitrate is NO3, while nitrite is NO2. And our goal here is to observe the efficiency of nitrite formation from nitrate photolysis. But in order to do that, we had to find a way to reduce nitrite concentration that's already in our cold room so that we can accurately see nitrite formation during illumination. So in figure 2, this is our cold room, which houses our snow making machine. From the left, we have these black canisters, which are our filters, and it's connected to these fans, these set of fans, which circulates air from the cold room and passes through this chamber. And this chamber holds our water tray as well as a heating element, where we incorporate principles of supersaturated water vapors to form snow crystals. So as steam is being made, as water is heated up, a flow of air pushes it through into this box. So this box has a bunch of nylon string that's attached horizontally left to right. And snow crystals would then form on these strings, and over time it would then just drop into our collection bin right here. So in an effort to reduce nitrite levels, we ran the snow machine for around 96 hours, typically from Monday to Friday. And every 24 hours, I would replace the filters with newly sodium bicarbonate coated filters, and I would then replace the plastic liners as well, so that by the time I get here on Friday morning, I would have the freshest snow as possible with as little nitrite concentration as possible. And so those samples are then taken to be illuminated by an arc lamp to simulate polar sun, and I would pull samples every 45 minutes with an accompanying dark control. After that, they're melted, and then I measured for nitrite concentration by absorbance with the colorimetric reagent. So this is what we found. Nitrite concentration during illumination had a slight increase. So this black line is our sample, and the green line is our dark control. And so this just kind of backs up evidence that nitrate does indeed create nitrite through photolysis. And we also found that if we ran the snow machine over the course of weeks, we were able to get nitrite concentration to be lowered. The blue line represents February 8th, and by March 22nd, as represented by the gray line, you can see a drop in nitrite concentration levels. And so what this means is that, yes, there's evidence of nitrite formation during illumination, but it has such a weak signal, right? And so what we're going to do in our future research is we're going to dope the snow with a known level of nitrate. And so what we're going to do is we're going to use this vapor deposition board in which we flow nitrogen through this tube, and then it goes through a pre-treatment, which is just snow. It goes around in this loop, and then it goes through our tube that holds ammonium nitrate, and the vapor forms of ammonium nitrate would then be passed along and land on our treated snow. So that's our way to dope snow. And so what we need to do is to test ammonium nitrate's ability to be vapor deposited on the snow first, and if that goes well, we will then illuminate it just as I've discussed before, and then study the reaction rate of nitrate. I just want to give a big thank you to the URC and the Provost's Undergraduate Fellowship, as well as the National Science Foundation for funding this project. and as well as the trio Ronald E. McNair program for helping me put this poster together. And a big thank you to you all for taking the time to watch this, and I hope you guys have a wonderful day. Thank you.